Note down these questions. These questions are from chapter 3. You will have to submit this homework in 2 weeks. Note down these questions. When the university will open, you will have to submit the hard copy of these questions. So now moving to today's class. So this is the first question for today. Using the tables for water, determine the specified property data at indicated states. In each case, locate the sketches on PV and TV diagram. So doing part A, we have to find temperature and internal energy. So pressure is given. Pressure is given 3 bar and specific volume is we have to draw a PV and a TV diagram. When we draw a TV diagram, we draw a line of constant pressure. So we are given 3 bar pressure and the specific volume. So if we go to the tables, so the pressure table is on page 929, in which the values are in respect to pressure. So if we go to pressure table 929 on page, and a pressure of 3 bar. If we go to the pressure of 3 bar, we find that the VF value at 3 bar is 1.07 into 10 raised to power minus 3, and the VG value is 0.6. R value is 0.5. So our V value is between the VF and VG, which means that this thing is in mixed vapor region. Note the value of UF and UG as well, because we have to find the internal energy at 3 bar. So since R value of V is between VF and VG, our state lies in the mixed vapor region. Now the tables have the VF value. The top of the table says VF into 10 raised to power 3, and on 3 bar, corresponding to 3 bar pressure, the value was 1.0732, which means that the entire table is multiplied by 10 raised to power 3. Why the entire table is multiplied by 10 raised to power 3? Because if it is not multiplied by 10 raised to power 3, we would have to write the table as 0.001732. So it will take more space. That is why they have multiplied the entire table by 10 raised to power 3. So this VF comes out to be, VF is 1.732 into 10 raised to power minus 3. So V equals VF plus X into VG minus VF. Everything is known apart from X. So X comes out to be 0.825. Then we have to find the internal energy. So this internal energy comes out to be 2196.7 kilojoule per kg. The temperature, so we had to find the internal energy as well as the temperature. The temperature from the temperature table is 133.6 degree Celsius. Now let's do part C. So part C is pressure is equals to 28 megapascal and temperature is 520 degree Celsius. Now we have to find which state is it. So we are given both pressure and temperature, which means that we can use both pressure and temperature tables. So if we use the pressure table, 28 megapascals. So 28 megapascals means 280 bar. So if we use table A or 520 degrees Celsius. If we go to the temperature table, the temperatures end at 374 degrees Celsius. Table A2 ends at 374. What about pressure? The pressure ends at 220 bar and we are given 280 bar. So the temperatures and the pressure that we are given are more than the mixed vapor region. So they have to be superheated. So if we go to the superheated region, table A4, so it starts with 0.006 megapascal. We are given 280 megapascals. So we are given 28 megapascal, 28 megapascal is this, and the temperature is 520. So first that the region is superheated because we are using the superheated table to find properties. Next we have to find the specific volume, which is this quantity, and the enthalpy, which is this quantity 3192.3. So these are the two answers. Next let's do part E. So part E has a pressure of 4 megapascals and a temperature of 160 degrees Celsius. So a pressure of 4 megapascals and a temperature of 160 degrees Celsius. So 160 degrees Celsius is in the mixed vapor region. One sixty degrees Celsius. 160 degrees Celsius is in the mixed vapor region with the pressure being 6.178 bar. But in part B we are given 40 bar. So our pressure is much higher. So for the same temperature, if the pressure is much higher, which means that we are in the solid region, which is ice. So compressed liquid water. So if we open this table, so 40 bar so there is a table for 25 bar and then there is a table of 50 bar. We are given 40 bar for a temperature of 160 degrees Celsius. Here we have temperatures of 140 and 180. And we have to find the specific volume and the internal energy. So we have to interpolate. So what do we have to interpolate? We have to interpolate the pressure because we have to find properties at 40 bar, and we also have to interpolate temperature because we have to find temperature of 160 degrees Celsius. So what are the values that we copy? we copy this specific volume, these two values. We copy these two internal energy. Then for 50 bar, we copy these two values and these two values. So if we copy all of them to the worksheet, so if we copy all of them, so we copy the V specific volume, then corresponding to 180 degrees Celsius. I'm not writing the units because there is not enough space. Okay, so the way to do it is that we have to first, we can interpolate the temperature or we can interpolate the pressure. So let's say we interpolate the temperature first. So we need to find all these properties. We need to find all of these properties for 160 degree Celsius. So 160 degrees Celsius is just between 140 and 180 degree. So if we take the average of all of these values, that we take average of this and this, we take the average of this value and this value, we get the specific volumes at 2.5 megapascal and 5 megapascal. So once we obtain the specific volumes at 2.5 and 5 megapascal, then we can interpolate for the pressure. So how will we obtain the specific volume for the pressure? So we would have, so let's say this is the unknown value V that we have to find. So we would know V value for 160 degrees Celsius and 2.5 megapascal. We would divide that with 4 megapascals minus 2.5 megapascals. Then we would equate it to the specific volume at we would equate it to the specific volume at 5 megapascals, 160 degrees Celsius, minus V at 2.5 megapascals, 160 degrees Celsius. Divide all of this with 5 minus 2.5. So in this question we had to double interpolate. We had to interpolate 2 times.